Hello students, welcome back. I hope you are doing good, right? So till the previous part we have discussed about the reactions of your aldehydes and ketones. There are some more nucleophilic addition reactions of your aldehydes and ketones which I will be discussing in this part. So let's start our session. Other reactions of your aldehydes and ketones. So in that, the next reaction is your Caneros reaction. Right? What is Caneros reaction? Caneros reaction is a self-oxidation and reduction reaction, and it is a reaction of aldehydes without alpha hydrogens. You know what is an alpha hydrogen, right? Alpha hydrogen is that hydrogen which is attached to an alpha carbon. And what is an alpha carbon? Alpha carbon is that carbon which is attached to your functional group. For example, if I consider CH3COH, in CH3COH, obviously, this is the functional group. The aldehyde group is the functional group here. So, this carbon will be your alpha carbon, and there are 3 hydrogens attached to your alpha carbon. That means there are 3 alpha hydrogens. But what about this? This carbon has no other carbon attached to it. That means there are no alpha carbons. That means there are no alpha hydrogens. So, I can say that formaldehyde undergoes your Caneros reaction because in formaldehyde there are no alpha hydrogens. Not only formaldehyde, your benzaldehyde. Even your benzaldehyde undergoes your Caneros reaction because this carbon will be your alpha carbon, and this carbon already has 2 bonds here. With this carbon, 1 bond and 1 bond. So 4 bonds are already filled and there is no scope for hydrogen. That means there are no alpha hydrogen for your benzaldehyde also. So yes, your benzaldehyde, and there is bromine present at your meta position, and in Caneros reaction, remember, you will be using NaOH, concentrated NaOH, and you will be getting what? You will be getting an alcohol, and not only an alcohol, you will be getting acetate. I mean, you will be getting a salt of your acetic acid or any other acid, right? So you will be getting an alcohol and you will be getting an acetate ion. So in Caneros reaction, the product formed is, hence it is proved that you will be getting an alcohol, and not only alcohol, and acetate ion. So you will be getting obviously there is bromine here at a meta position. There is no effect to the bromine at the meta position. Here also there is no effect to the bromine present at the meta position. So and hence Caneros reaction is a self-oxidation and reduction process. One is getting oxidized and other is getting reduced. So formaldehyde is the most easily oxidized aldehyde. When mixed with another aldehyde that doesn't have any alpha hydrogen, so both the aldehydes doesn't have any alpha hydrogen, and you are using concentrated NaOH, right? And remember, since there are 2 aldehydes now, one aldehyde will be oxidized and other will be reduced. You know that aldehyde can be oxidized to acid, aldehyde can be reduced to alcohol. Yes, the same aldehyde is now oxidized to acid and reduced to your alcohol. So cross Caneros reaction. So cross Caneros reaction is possible when you are using one aldehyde of one type and another aldehyde of another type. So here the same thing is happening. In vanillin is reacting with formaldehyde. Both are aldehydes and both don't have alpha hydrogens. So when they react, this is called cross Caneros reaction. Why cross? Because there are 2 different types of aldehydes reacting. So you will be again using concentrated NaOH, and yes, you know that you will be getting an alcohol and you will be getting an acetate ion or carboxylic acid ion, right? So this is a cross Caneros reaction. Next reaction is addition of GNAR reagent. What happens when I add a GNAR reagent to your aldehyde, right, or ketone? So you know what is GNAR reagent, right? GNAR reagent is nothing but an alkyl group with magnesium and halide. So RMGX. So RMGX is your GNAR reagent, and now I am adding it to a ketone here. So what happens is in GNAR reagent, since magnesium is an electropositive element, so magnesium will be converted into magnesium has a positive charge, partial positive charge, and this alkyl group has a partial negative charge. And I already told that in the carbonyl carbon there is a partially positive charge on the carbon and partially negative charge on the oxygen. So obviously this partially negative charge alkyl group attacks the carbon which is partially positive already, and this oxygen which is already partially electronegative is getting attacked by magnesium which is already partially electropositive. So you will be getting OMgR. Now if I hydrolyze this further, what you will be getting is you will be getting an alcoholic group. So this there will be OH formation when I add an alcohol, and I will be getting an alcohol, right? So what I am getting is I am not only getting an additional alkyl group attached to my carbonyl carbon, alright, I am getting an alcoholic group. That means I will be getting a larger alcohol. So I will be getting a larger alcohol. So Gad reagent, you will be getting an alcohol from your Gad reagent, that to higher alcohol, remember this, and that too from your ketone or aldehyde. So mechanism is given here. So this R minus, I already told you, it attacks this carbon. Then what happens is you will be getting O minus, and MgBr will be getting added in the second step. So remember, this step is a rate determinant step or it's a slow step. So you will be getting OMgBr. So synthesis of alcohols, right? Gad reagent is used for synthesis of alcohol, that too higher order alcohols. So for formaldehyde, from formaldehyde, if it is an aldehyde and using Gad reagent, you will be getting a 1 degree alcohol, right? And if you have other aldehydes, for example, right, instead of formaldehyde you have R-COH, the same Gad reagent and undergoes hydrolysis, you will be getting a 2 degree alcohol. So you can get a 1 degree alcohol, 2 degree alcohol, and not only that, you can get a 3 degree alcohol from your ketone. So that is the beauty of your Gad reagent, guys, right? You can get a 1 degree alcohol, 2 degree alcohol and 3 degree alcohol. So here if I use a ketone, I will get a 3 degree alcohol, and if I have the same Gad reagent here and with this ketone, I will be getting a 3 degree alcohol. So instead of your aldehyde and ketone, I will be using ethylene oxide. So what happens if I use ethylene oxide? The same thing, just like for your formaldehyde, you will be getting an alcohol. So Gad reagent is that a very important process in generating alcohols, right? And remember, the carbon, the alcohol carbon come from the carbonyl compound, right? Right. For example, you have RCOR dash. This carbon of alcohol comes from the carbonyl carbon itself. But remember, where this new carbon, for example, you will be getting the final product is this OH, this is OH, and you will be getting R dash and you will be getting R double dash. So the carbon present in this R double dash is from the carbon present in the Gad reagent. So the new carbon bond, right, is from the Gad reagent. So the alcohol which is coming, which is attached to the alcohol, is the carbon which is already present in your aldehyde or ketone. So you can see this R marked in a red format, R is getting attacked here. So you will be getting an alcohol here, and this R is getting attached to carbon. So new carbon bond. Yes, now there is a GNAR song, you know. There is actually a famous, beautiful song regarding Gad reagent. So what it says is that the carbonyl is polarized. Obviously you know that carbonyl groups are polarized, and the carbon end is plus. Yes, carbon end, know that there is a partially positive charge, so the carbon end is plus. The nucleophile does attack. The nucleophile will does attack, right? For example, R minus MgX. So this R minus is a nucleophile. Nucleophile always attacks this carbon. So the nucleophile does attack the carbon nucleus, right? So the Gad yields an alcohol of types 3 or but 3. The Gad yields an alcohol of types there are but 3. That means there are 3 alcohols which can be possible. It makes a bond that corresponds from C to shining C. Why shining C? Because now this shining C has an alcohol. So this is one of the Grignard song. So in Grignard song, actually tells us what exactly happening in your Grignard reaction or reaction of your aldehyde ketone with your Grignard reagent. So you can see here, you have ketone, again you have Grignard reagent. So this group will be present here and you will be getting a 2-methyl-2-hexanol. The same thing, you will be getting a 2-methyl-2-hexanol, right? If you are using this as a ketone and this as your Grignard reagent, so that is the beauty of your Grignard reagent. You can get 2-methyl-2-hexanol via this type of ketone and you can get 2-methyl-2-hexanol using this type of ketone. So you can interchange both of them to get the same alcohol. So obviously the summary is that if I have an alcohol, if I have an aldehyde, you will be getting a RMJX, which is Grignard reagent, and you have alcohol and you oxidize this alcohol, you will be getting aldehyde, you can get a higher alcohol. So a smaller alcohol can be converted into larger alcohol, right, by using Grignard reagent. How? I have to first convert into aldehyde or ketone, then use Grignard reagent, then I will be getting a larger alcohol. So you can see now Grignard synthesis of 4-methyl-2-pentanol, right. So from alcohols, so I have 4 carbons. I have 4 carbons in the Grignard reagent and I have an aldehyde, and these 2 carbons gets added to your aldehyde and we will getting alcohol. So step 1 will be it determines the carbonyl compound Grignard reagent that you would use obviously, and step 2 shows the synthesis of Grignard reagent and carbonyl compound from your alcohols. So again you will be getting the same thing. First, for example, you have benzene, right? Benzene, you just get bromobenzene, and now this is what a Grignard reagent. Now what I am doing is I have an alcohol. You know that if I oxidize an alcohol, I will be getting an aldehyde and ketone, and this ketone with this Grignard reagent will get you 2-phenyl-2-propanol. So just from your 2-ethanol, I will be getting 2-phenyl-2-propanol using benzene. So similarly, I can get 1-methyl-cyclohexanol if you have an alcohol, right? That alcohol can be converted to Grignard reagent, cyclohexanol that can be converted into cyclohexanone. We will be getting again 1-methyl-cyclohexanol, right? So what can you understand from this is that I can convert my alcohol. If I have a lower chain alcohol, I can convert into a higher chain alcohol using an intermediate reaction with Grignard reagent. Here also, right, methyl alcohol. You have a methyl alcohol, then oxidize it using K2Cr2O7. You will get an aldehyde, then have Grignard reagent, then hydrolyze it, then you will get cyclohexyl methanol. Now concept check. So you have to identify the aldehydes which can give Caneros reaction, right? So obviously the logic is you need such compounds with no alpha hydrogen. So if you can look into this, obviously this has no alpha hydrogen, this has no alpha hydrogen, right, and this seems to be not an aldehyde itself, and this consists of alpha hydrogen, so it won't be giving your Caneros reaction. So obviously A and D. Now if you see the answer, there is C also coming, right? Why? Because there is one important logic, guys. So one, obviously A and D do not have alpha hydrogens. A and D do not have alpha hydrogens. Obviously they give Caneros reaction, right? But remember, B has alpha hydrogen, even though B has alpha hydrogen, there is a concept of steric hindrance, right? You have to consider the concept of steric hindrance. When you consider the concept of steric hindrance, right? Because of that, even though you have alpha hydrogen, then also it gives your Caneros reaction. This is a very important point, right? So yes, because of steric hindrance, B also gives Caneros reaction. And what about C? So don't you think this is possible? Since you are using a basic medium, CH3CA, CHCl2, right? So this converts, you have two chlorines will be removed and substituted by alcohols. We'll be getting two alcohols here. And finally, if I heat it, I will get an aldehyde without alpha hydrogen. So hence this can also give Caneros reaction. So the answer is A, B, C, D. So all of this above, all the A, B, C, D can give Caneros reaction. So these are the two important points, right? C actually don't have your alpha hydrogens, but also can give and can also react, right, with sodium hydroxide to give Caneros reaction, because the alcohols will be formed by removing of chlorine, and again dehydration takes place to give an aldehyde, right? And B, since because of steric hindrance, right, it gives Caneros reaction. So students, these are the different chemical properties like oxidation, reduction and other nucleophilic addition reactions of your aldehydes and ketones, right? So we have now understood how can we prepare different alcohols and carboxylic acids from your aldehydes and ketones. So in our next part, we will be discussing about an interesting part. Can you guess what is that interesting part? Yes, the interesting part is your previous year questions. We will discuss about your previous year IIT-JEE questions, your previous year APMT questions and AEEE questions, right? So till then, stay tuned to our sessions. Take care. Goodbye.